So this is going to be a quick skills session on tables of data. I've tried to find three different kind of tables. So let's have a look at this first one. So we're investigating the effect of mycorrhizal fungus on pea plants with nitrate and ammonium fertilizers. Identical fertilizers. I've trimmed off other questions that they asked about, so some of this information is not necessary. And I've got pea plants in four groups. So these A, B, C, D match what's in this table here, just to avoid having to go through it twice. Yeah, the heat-treated fungus had been heated for 120 degrees C for 1 hour, and the results are shown in the table. So this is where I'd use my highlighter pen to kind of highlight little bits here, because A is heat-treated, C is heat-treated. So those two, or there's dead fungus. It's been heated for 120 degrees C for an hour. It's going to be dead. So there's no fungus there in effect. Whereas B, the fungus is alive, and I guess that's nitrate and nitrate. So A and B are a nitrate comparison, and ammonium and ammonium. C and D are an ammonia comparison. So let's look at the oops. So yeah, what conclusions can be drawn from the data in the table about the following? So I've got the effect of the fungus on the growth of the pea plant. Right. So I'm going to I can do a little bits of comparison here. Well, because A and B are without fungus and with fungus. So yeah, the fungus has caused a lot more growth. I look at this standard deviation. And yeah, there's no overlap on the standard deviation. 0.4 plus 0.05 is still less than 1.61 minus 0.28. So yeah, so it causes, the fungus is causing the roots to grow more. And if I look over here, yeah, the shoots grow more as well. Compare C and D as well. And it's a bit tighter, but it still had an effect in that the fungus has caused more growth of the roots and it's caused more growth of the shoots. Again, there is no overlap. So that's my first one that I can write, in that the fungus caused, got for fungus, sorry, fungus causes increased growth of root and shoot. I just put root and shoot. It says pea plants, and it's given me the root and the shoot. So that's comparing A and B and C and D. Next, as I was looking through those numbers here, yeah, so the one with nitrates, it's grown by 1.61. However, here with the fungus, the ammonia is only grown by 0.96, and the shoots grow a lot more. Yeah, so the nitrates having more of an effect when the fungus is present. So yeah, so the fungus increases growth more with nitrates. I'm looking for things that I can say that are correct. So yeah, fungus causes more growth with nitrates than ammonium. So yeah, so there was quite a bit to do for that one because I was comparing the effect of the fungus. There's many different variables here, so I just have to, I've used every single number in that question, and then I have to do the effect of nitrate fertilizer on and ammonium fertilizer on the growth of pea plants. Right. So now, well, I'm gonna use the heat treated ones here because it's just the fertilizer. I want to take the fungus out of the equation. So it's the ones that I've highlighted red that I'm comparing. So I'm comparing 0.4 to 0.34. All right. Well, they're close. Yeah. If I add on 0.03, that's 0.37. 0.35 would be 0.4 minus 0.05. So I've got overlap between these two. and I've got overlap here as well. Yeah, they're very similar. Um, so yeah, the effect of nitrate fertilizer and ammonium fertilizer, they have a very similar effect, and it's not significant because the standard deviations overlap. That's all I have to say. It's nice and easy. Yeah, so that's far easier. So there's um, no sig difference, no sig diff between them. As the SDs overlap. Yeah, growth is similar with both. Yes, that's an easier 2 marks than the first 2 marks where I was able to compare everything. So yeah, so I guess the key bit about the question is knowing that by heat treating the fungus, effectively we are removing the fungus. Let's look at the next one. So the table shows the effect of increasing CO2 on the rate of photosynthesis in maize. Describe and explain the effect of increasing carbon dioxide on the rate of photosynthesis. This is probably a bit too easy, but it shows it reasonably clearly at least. So I've got my CO2 increasing in arbitrary units, and the rate of photosynthesis is also increasing. Some people do this when the numbers are more awkward. I'd be putting like little arrows between these. It's increasing, it's increasing, it's increasing, it's increasing, it's increasing. There's no change, right? So that's where my max is reached. So my describe is, yeah, as CO2 increases, so does the rate of photosynthesis, so does the rate of photosynthesis until a max at 300. Oops, it's A dot U dot arbitrary units of CO2. That's probably a 1 mark describe. I have to explain why. It increases with CO2 as CO2 is needed. Reacts with RUBP to form 2 times GP in the light independent reaction. As in it's needed for photosynthesis. I'm just showing off a bit. And there must be some other limiting factor. There's some other limiting factor. Could be light. At 400 CO2 arbitrary units. So yes, it's just looking for the pattern in the numbers. You can't just say it increases because it doesn't increase between 300 and 400. Really look out for stuff like that. Sometimes you get things where it's like there's hardly any change. It's kind of going up and down, up and down, up and down, and then it changes, and therefore you can say like it fluctuates at a low level up until this value, and then it starts to increase by this much. Again, just be careful with tables. Again, they often put a trick in there. If you actually describe numbers in the table, they do tend to make it a bit awkward. That one seemed a bit more GCSE than anything, but it was the only one I could find as I was looking a minute ago. Let's do number 3 because this is another one where the scientists recorded the number of each species of butterfly caught in traps. Again, there was a question before this explaining things. The table below summarises their results. So yeah, these are the different species of butterflies captured. The canopy is in the leaves of a tree. The understory is under the tree, in like the grasses and bushes and things. And the scientists carried out stats tests to see if there's a difference in distribution of each species between the canopy and the understory. Right, so I'm comparing these across, and they've done a stats test and given me a p-value. The p-values obtained are shown in the table. Explain what the results of these stats tests show. Well, they are all significant apart from one. get my highlighter out again. So significant, 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 and they're all the same level of significance. However, that one's greater than 0.05. So get my little pen ready. So that's the one that I'm going to point out. Yeah, it's Z Itius. Its difference in distribution, because there is a difference in distribution, is not significant. Yeah, because I've got 25 and 11. And then I just write my statement I always write. There is greater than 5% probability that the difference, so this is messy, is due to chance. Yeah, so that's probably due to chance. All the others are significant. And then it's just understanding what this less than 0.01 means. Well, less than 0.05 is 5%. So I can say, yeah, that there is less than. So if my symbol's less than, I say less than, there is less than, and this is 0.1% probability that the difference is due to chance. It's worth saying, I think, that we require less than 0.5 or 5% probability. So this is, this with pen. This is less than or more significant. This is less than, pen, the 5% probability required. There we go. Got my 3 marks. Yeah, so pointing out which ones is not significant, pointing out the ones that are significant and to the level that they are significant. And I'm just writing the same thing, probability and chance each time, as I would do any kind of stats test. Again, sometimes if there were some of these where, again, sometimes, just to kind of show you quickly, because I've got a couple of minutes, sometimes that one could be like less than 0.1. I'd say the same thing, exactly the same thing. Yeah, I require it to be less than 0.05, less than 0.1 doesn't matter. I'd be saying, it's difference. The difference in distribution is not significant because there's greater than 5% probability. The difference is due to chance if it was less than 0.1. So yeah, it can show it like that instead. Anyway, that's a bit of table fun, so I shall leave it at that.